Hey everyone, I wanted to give you a quick introduction to single replacement reactions, which is what you're going to be learning about in the lab that you're going to be doing for the next few days. So to get us started, let's take a look at a phenomena that demonstrates a single replacement reaction. It's going to go really quick. I sped up the video for you. Okay, so you can see when we start here, let me back it up to the beginning. Well, we start here, we have a clear solution. We're going to add to it a piece of copper metal, and the copper is going to become coated, as you can see, and the solution is going to turn blue. So this is a reaction of copper metal being put into a solution of silver nitrate. And you can see that we form a solid metal on the copper and that the solution turns blue. So those are the two main observations that we should think about with this particular reaction. And here's some really cool pictures of what that looks like after a few minutes. Okay, so what are we hoping to accomplish in this lesson? Right, we want to be able to describe what an activity series is. We'll talk about that in a minute, and then be able to predict what the products are going to be of a single replacement reaction. So by now you should have some basic vocabulary, at the ready. And the new thing that we're going to talk about today is activity series. So, single replacement reactions, if you recall, a single element, typically a metal, replaces another element in a compound. These can also be called single displacement reactions. So, a single element displaces a second element that is already in a compound. The definition of it in words can be kind of awkward, right? But if we look at the general equation for it, it becomes a little bit clearer. So, we have a single element A combining with a compound, B, C. And you can see that the single element A has basically replaced or displaced the element B in the compound. So the new compound that forms is AC, and the B gets kicked out, right? So it's been displaced or it's been replaced in the compound. And you could see that this is occurring with a metal because A is replacing B, and B is the first element in the compound. So it must be the metal in the compound BC. So A is replacing B. This is what it would look like for a metal. We can also have single replacement reactions with nonmetals, specifically just the halogens. So in this case, you can see that A is not replacing B, but A is replacing C in this reaction, which would be the nonmetal. To visualize this, I like the puzzle piece analogy here because the pieces can only go together a certain way. So when A is the metal, it has lost electrons, right? It's going to become a cation. It can only replace B in the compound BC. That's the only way the puzzle pieces are going to fit together. And so B has been replaced, and the new compound is going to be AC, and the metal B will be left by itself. If you have the halogen single replacement, you could see A there is looks like the other side of the puzzle now. So the only thing that it can replace in this reaction is element C, right? It can't replace B anymore because the puzzle pieces wouldn't fit together. So it would have to replace C in this reaction, and you end up with BA as your compound and C getting kicked out of the compound. So the question that we have for today and for your lab is, does this reaction always work? Can you always just put a metal into a solution and end up with a single replacement reaction? So, for example, the reaction that we saw before, copper going into silver nitrate, will it work the other way? If I take a piece of silver and I stick it into a copper nitrate solution, what is going to happen? And the answer is nothing. Okay? So when I stick the copper into the silver solution, I get a pretty cool reaction where the silver comes out of the solution and the copper goes into the solution. But if I do the opposite, if I stick the silver into the copper solution, nothing is going to happen. It could sit here for a year. The only thing that would happen is your water would evaporate. But the silver will never go into that solution and the copper will never come out of that solution. So the question is, why does that happen? And knowing that that happens, that sometimes the reaction will work and sometimes it won't, how can we predict whether or not the reaction is going to take place? And so, what we have to know is how reactive the metals that we're dealing with are. So, metals have different levels of reactivity compared to each other, so they're relative to each other. What we do is lots of experiments, just like the one that you saw, where we stick metal into a solution and we see if a reaction occurs. And we do that with lots of different metals, with lots of different solutions. And based on those results, we can determine whether or not a reaction is going to occur. So the reaction we saw in the video was this one, solid copper going into a silver nitrate solution. The silver is displaced and the copper becomes copper nitrate in solution. But the reaction in reverse does not take place. So because if I know this, if I've done this experimentally, and I see that the copper has a reaction with the silver nitrate, but that silver does not have a reaction with copper nitrate, I can tell that the copper is more reactive than the silver. Why? Because the copper is able to replace the silver in the compound. Silver is not able to replace the copper in the compound. So the copper is more reactive than the silver. Now, if I do this lots of times with lots of different metals and lots of different solutions, I can create something called an activity series. So I can rank the metals in terms of which ones are most reactive and which ones are least reactive. And this is what that kind of ranking is going to look like. Basic metals that we have here, common metals, and ranked from most reactive at the top to least reactive at the bottom. Okay. Also, hydrogen happens to be in there if you notice, and hydrogen can act like a cation in ionic compounds. So it is also a part of our activity series, even though it is not strictly a metal. So we can use the activity series as a reference to predict whether or not single replacement reactions are going to occur. What you're going to do over the next couple of days is create your own activity series of metals. So you're going to simulate what you saw in the video, sticking metals into solutions and determining whether or not reactions occur. Based on those reactions, you're going to be able to order the metals that you're given from most reactive to least reactive. So now it's time for you to go ahead on to the pre-lab and get started on today's assignment.